I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. Today I'll talk about creating custom styles with arguments in TikZ. Styles are ubiquitous in TikZ and PGF plots and appear in one way or another in every drawing. I already made a video on custom styles and linked to it in today's show notes. I recommend that you watch that one first if you haven't already seen it. In this video, I'll explain how to create custom styles with input arguments, making custom styles even more powerful. I'm focusing on TikZ, but everything I say will also apply to PGF plots. The videos on this channel are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials. Our focus today is on styles with TikZ. Here is the preamble for the document that we'll be creating. I'm using a document with a special size, just 3 inches wide, to make things a bit easier for you to view. This is not a recommended page width, but it works for this purpose. Hopefully, this will enable you to see more of the LaTeX code while also being able to see the output clearly. For this reason, I'm using the geometry package and setting the paper width and the margins. I'm also using parskip to make things look nice and hyperref to link the author name back to the YouTube channel. The essential package today is, of course, TikZ. Today, we'll also be using the positioning library for the convenience of placing nodes in our pictures. No special packages are needed beyond TikZ for specifying TikZ styles with arguments. Okay, so I'm going to show you how to use styles with arguments. Let's get set up by drawing a picture with 3 nodes. I've covered nodes in another episode, which I've linked in the show notes. So here's our first little picture. I'm defining a style in the optional arguments, and all it's saying is to draw whatever uses this style. I create 3 nodes along this path, all using the style tipsy. One is apple, one has the text banana, and then the last one has the text cherry. And you see the result over here on the right. I can add rotate equals $1 to the style. However, when I recompile that, I get an error. So the $1 says use the input argument, but I didn't specify any rotation inputs to my styles. And so now I get an error in my code. So the way that I can fix this is either go through and say equals a value for every time I use tipsy, or I can set a default value, which is what I do here. I'm setting the default to be 0 degrees. Now that error message goes away. Now let's set some of the angles. So maybe for the first node, I'll set the angle to be 90 degrees. And for the second node, I'll set the angle to be minus 45 degrees. When I compile that, you see that I've rotated apple by 90 degrees and banana by minus 45 degrees. I can also change the default to be anything I want. So maybe I want everything to be upside down if I haven't specified anything. So if I change that to 180, we see cherry is flipped over exactly as we specified. Now let me post another TikZ picture that gives you one of my favorite uses of customized styles. For this one, I'm using the positioning library. I set the style of every node here to be a circle and to be drawn. I'm just drawing 2 nodes, an A and a B. I'm using the positioning library to say that B should be above right of A. Then I'm drawing a 2-headed arrow between these 2 nodes. The problem is that the arrow is a little bit hard to see because it goes right up to the edge of the node. What I'd really like to do is shorten it at both ends. So I can do this by using the shorten greater than and the shorten less than keys, as I'll show you by pasting it here. So I paste that, and now I recompile, and now we see we have our shorter arrows. The problem with this is that it's a lot of typing. I can instead define a style with an argument that shortens both ends by the same amount. I'll do this using the TikZ set command, which you might normally want to just go ahead and put in the document preamble. So I'll put it before my picture. TikZ set applies to everything that comes after it. And I'm defining a style named Shorten. It takes 1 argument and it passes it to both the shorten greater and shorten less than keys. I don't bother with a default value because I'm assuming that I'll always pass some amount, but you can of course specify a default value. Now I can just make this a single command that's just shorten equals 1 millimeter, and I can take out this and recompile, and we get the same thing as before. This makes it easier if I want to change it. So for example, if I decide instead I want 2 millimeters, I only have to change that in one place. Now I can play around with whatever I want and how I want my arrow to be shortened. That gives me a lot more flexibility. Let's do another example. Here I'm defining a style named circ. It takes a color as an input and it uses that to draw the outside of the node and to fill the inside with 20% of that color. The text is set explicitly to be black, and I'm setting here the default color to be blue. I create two nodes, A and B. A uses the default color of blue and B uses the color orange. And so you can see the result over here to the right. Now I want to show you that you can actually override the options inside the style. Suppose I decide that I want the fill of node B to be yellow instead of the default 20% orange. If I add fill equals yellow after I specify circ equals orange, it will actually override the fill that was specified in the circ style. And that's because it came after the specification of circ. If I had put it before the circ style, it wouldn't have had any effect. But you can always override these things that happen in the styles, even if they have arguments. In this last part, I'll just show that we are not limited to a single argument for a style. We can use a special key, style and args. Let me give an example of that. I'm going to create a custom type, which I'm going to call matrix, and it's a node with 3 inputs. So I do matrix / dot style and args, and then equals 3 in curly braces. And then in the remainder, the second pair of curly braces, I actually define the style using those 3 arguments. So I'm setting this to be a node that is ultra thick lines. It's drawn. The fill is 50% of whatever color. The anchor is at the northwest corner. And then where I use the inputs is that the minimum height is number 1 millimeters, minimum width is number 2 millimeters. And then I'm going to put a label above. We used labels in a prior episode. So I'm going to put a label above that is in math font, the whatever my third input is. I talk about anchors in another episode, which I'll also link in the show notes. Now let's create a picture using this style that we've just created. So let me paste that code here. I'm creating first just a single matrix node A that is orange, and then it's size 15 by 10 millimeters. I'm using A in its label, and I've also given it the name A here in parentheses. Next, I'll add an equal sign to the right of A. And so that's just a plain text node. I'm not using any style here. And that just goes to the right of the node A. Then I'll add another matrix with the name and label U. It'll be the same size as A and to the right of the equal sign. So here you see where I'm using this command with 3 arguments. And then I'm just putting it to the right of the equal sign. Next, I'll add a 10 by 10 matrix after that with the label sigma. I'm aligning its anchor in the northwest with the U dot northeast corner. Okay, and then I'm doing an X shift of 1 millimeter. That's how they're not right up against each other. So I shifted it over a little bit, and then notice that it's empty. That's because I did fill equals none here. So I've actually overridden the default fill. Next, I'm going to draw a diagonal line from the upper left to lower right corner of this matrix, which has the label of sigma, but I named it S just to be more convenient. And then I draw that line from the upper left to the lower right. This is denoting a diagonal matrix in linear algebra. So here, one thing to note is that I am using that shorten thing that we defined earlier, because if you actually have it go all the way, it sticks out a little bit because we're using these ultra thick lines. Finally, I'll create a matrix V after all of this, and it will be a 10 by 10 matrix as well. I'll give it the label of V transpose, and then I'll give it the name of V. I'm putting it at S dot northeast, and I'm again shifting it over by 1 millimeter. So now I've drawn an iconic equation in linear algebra, which is the matrix singular value decomposition. I hope you enjoyed today's episode on styles with arguments. I focused here on TikZ, but what I've said should also apply to PGF plots. If you have a specific question about using this with PGF plots, please post a question in the comments. I include a link to the Overleaf document I created today in the show notes so you can go play with it yourself. If you found this helpful or interesting, please click like or subscribe. If you have TikZ or PGF plots questions, please post them in the comments or send me a message. If you want to learn more, please check out the other videos. I also have a book, Unlocking LaTeX Graphics, available for purchase at major book retailers. Thanks for watching.